Hey everyone, my name's Joe and welcome to part 23 of the Godot top-down shooter tutorial. In this one, I'm going to show you how to take the pathfinding algorithms that we've written and improved on over the last few videos and how to draw debug information to help you see what's going on like we're doing here. So you can see that all the tiles that are currently available have kind of a blue tint, and then whenever you or an AI unit goes over one, it'll be marked red to show that that tile is currently not an enabled tile in our navigation grid. We'll also go over how you can draw the current paths of AI units so that you can kind of better help debug where they're actually going. So with that, let's get started. So we've already finished our pathfinding implementation. We have pathfinding that works, it takes into account walls, and we have some code that you can uncomment out if you want that will handle avoiding other units. So we've got a lot of our pathfinding there. It's pretty robust, it works pretty well, even despite some weird visual stuff or some, it's not always perfect. But what I want to do in this video is just show you quickly how you can draw some UI elements that'll help you debug and see visually what's going on with your pathfinding, just so that you can see in-game and kind of help you understand what's going on if you're seeing something you're confused about, or if you're trying to make changes and tweaks to your pathfinding. It's just a helpful way to see those in action. So there's two things we're going to do. One is we're going to draw a line for each actor on the screen showing their current path. And the other thing is we're going to draw a grid overlay for our game that draws like a dot or a rectangle at each point in our navigation grid, and it'll draw blue if it's active and red if it's active is the wrong word. It'll draw blue if it's enabled and red if it's disabled, which means it's blocked by either a wall or, in some cases, if you're using that code, a unit. So let's get started with that. The first thing we're going to do is come into our AI script. So if I go into our ally and see AI here, what I'm actually going to do is save this as a scene. I'm surprised we didn't do that already, but I'm going to save AI as a scene there. Come into our enemy, do the same thing. I'm going to get rid of our AI that exists and then re-add it as our AI scene, an instance of that. So I'll just drag that up there. Should just work as it did before. I'll just run this quick just to make sure I didn't just break everything. Let's just make sure that our enemies are also still working and can navigate. Oh man, I'm still so excited about the pathfinding, guys. It's pretty sweet, pretty cool. So we see these guys. That was kind of weird. Oh, you know what? I might have forgot. Oh no, guys, I'm just realizing as I did this that I forgot at the end of that last video where I was showing you how you might go about adding pathfinding that avoids enemy units. I totally forgot to change this back to just use the ranges rather than these points. So let me just so 4x in range 3, 4y in range 3. Let's just add these back. I'm so sorry, but I guess better to catch this now. No, vector 2 x minus 1 y minus 1. Okay, so now we will have we'll be using diagonal connections again, which will be good. And on last video I think I said I was going to do a branch, but I've kept all the code in here for having unit avoidance in the game. It's just commented out, so if we wanted to use this, we could just comment it back in and then we'd be able to see it, which we probably will, just to make sure it's working when we do when we actually draw in our grid. So anyway, that said, let's open up our new AI scene. So I saved it under actors, I believe. Yeah, so if I open up AI.scene, tscene. Okay, so let's add a line 2D here. So a line 2D, if you've never used it before, is just what it says. It's a line, you give it an array of points, so it doesn't just have to be 2 points. It can be, as curvy or whatever as you want, but it's just a line. So we'll do a line of width 2. We'll set it to this nice, let's do like a gray so it's not super obstructive or super obstructing of your view. So we'll set it a gray, width of 2. You can give it a width curve so it gets smaller or larger over time. I do like to make it round at the caps so that it's not just like a rectangle, but it's kind of rounded, which can be a little nice. And then the joint mode we'll just make round 2. So it's a little bit of a smoother curve, but it doesn't really matter. And we'll call this path line. Okay. And so now in our AI script here, I can do onReady var path line, and this is going to be path line, as you can imagine. So whenever we're getting a new path, we want to set the points for this path line. So in order to do that, we're going to add a new function to our AI. I'll just add it after initialize, and we'll say function set path line here. And this is just going to take a points array, which will just be our path basically. And so remember, here's the weird thing is that we do some work in our pathfinding to convert the path we get back from our navigation system to be world points. Well, now we kind of need to convert it back to be local relative points, not in tile coordinates, but relative to our actor, to our AI, so that our path is relative to where they're currently at. So what I'm going to do is say var local points, because these will be our points that we're passing in translated to an array of localized coordinates. And this will just be an array, and I'll just use this notation here to automatically type it rather than having to type out array here like that. So we'll do that, and then I'm going to say for points, in points, and then I'm going to say local points dot append. And so when you draw a line, this points array, these all need to be relative points. So 0, 0 is going to draw wherever the origin of the line is. So we need to convert to relative points starting at 0, 0. So in order to do that, because these points are going to be global, we need to take point minus global position. So it's going to get us the difference between the world coordinates of the point and the world coordinate of our actor, which is going to give us that difference is the relative coordinate, how far away it is from the actor itself. So this is going to make it so that our line correctly draws where it needs to be. It's going to line up with our actor. And then finally, we can say pathline.points equals local points. So this function is going to draw that path line. Now we just need to call this function. So there's two places we're getting a new path. We are going to, down here, I think let's do it within, let's do it in here. So whenever we're moving, we can say set path line. So whenever we're patrolling and we get a new path and it's a valid path, there's actually points in it, we can just do path. So we'll set the path line there. And we will also do the same thing in our patrol. Oh, I thought we were in our patrol state. That was our advanced state. We'll do the same thing for our patrol state. So now if I run this, I believe we should see it. It should be good. So yes, you can see the lines, but they're being rotated pretty crazily with people. And the reason why is, again, path lines are relative. So we need to make sure that it is not rotating with our actor. Easiest way to do that is just each physics process, say pathline.global rotation, and set it to 0. So we just continuously reset its rotation to 0. Not the most amazing way to do it, but now you can see that we have straight path lines that are getting taken by our units. And you're actually seeing the path lines from our enemies too, as they're all heading over here, which is pretty cool. And look, you can see it updates when we patrol. Now there's a couple problems. As one, you'll notice that, let me start this again. One you'll notice is that when our units patrol and they get to the end, it doesn't actually clear out the path. So like, see, he's done here, but there's still a path there. So we need to get rid of that. Also, our path is centered at the tile that they're currently on, and it's not centered on the unit itself. So we should change that as well. So first one is just clearing the path. So whenever we reach the end of our patrol state, we should say pathline.clear points. And whenever we reach the end of our engage state, we should also say pathline.clear points. And now if we run this, we'll see that once our actors get where they're going, that the line will be cleared so it doesn't look like they're still moving. So boom, it's gone, gone, gone. So then when these start to patrol, we'll see it again, and then it's gone. So that's good. Now we just need to make sure that our path is actually centered on our actor so it doesn't look kind of weird like that. And in order to do that, what we can say is we basically want to check if this is the first point in this array. If the index is 1, then we just want to override that point to just be the current position of, or 0, 0 really, to be wherever the actor is, because remember, these are local coordinates. So what we can do is say if point equals points of 0, and we don't have to check to make sure there's actually a 0, a first element in that array, because we wouldn't get here because we're doing a for loop. We wouldn't get here if that wasn't the case. So if the point we're currently on is the first point, we can just say local points dot append, and this will be vector2 dot 0, because again, relative coordinates, so we just want it to be right on 0, 0, wherever our actor is. And then for all the other points, we append the difference between the point and the global position of our actor. So now you should see that as our unit moves, this position follows them, and it continues to update. So it looks a lot nicer, a lot cleaner, and less weird. So again, we're still seeing some collisions there, but for the most part, like, we're pretty much here. And for our enemies, you can see that if I move in the way of their path, oh, that's right, we don't have unit collision detection on right now, so they're not actually going to change their path. But so now you have a way to see to draw these paths to see where all your units are going, which is great. And one thing that we can do to make this a little bit easier, again, one nice thing is you can have like a global debug variable, so that whenever you're in debug mode, quote unquote, it'll draw these things, and otherwise it won't, that you can just flip on or off. There's also some built-in ways to Godot, like constants you can read to determine like your runtime environment. But for something like this, the easiest way for me is I just like to do, let's do it right here. Let's do export bool and var, and this will be should draw path line. And this will be false by default, and then we can just flip it on here. And so if it's on, we'll draw it. If not, we won't. And so with that, what we can do is say on ready, we'll say pathline dot visible, and we'll say this equals should draw pathline. So if we should draw it, it'll be visible, otherwise it won't be. And then we can just say if not should draw pathline return. So if we shouldn't draw it, there's no point in updating it, and we'll just return. So right now, if I run the game and I have it off, we'll see no path lines. There we go. And if I flip it on, run this game, and path lines, there they are. Cool, guys. So that's the first one. Now we can see our agent paths and the paths that they're taking. Now I want to do the more interesting or more fun one, I guess, which is looking at drawing our actual grid. So this is kind of an interesting case. Let me go back to our main. What I'm going to do is actually save our pathfinding. Currently it's just a node with a script, but I'm actually going to save this as a scene. So I'll just save it. Let's just do it in our root directory. We don't really have anything else in here for this. So I'll just do pathfinding, and then I'll open this scene, our new pathfinding scene. And what I'm going to do is add another node 2D here, and I'm just going to call this grid. And so what we're actually going to do is add a bunch of colored recs, which are UI elements, to our game. So if I do color recs, and what we're going to do is we're going to control their size and position from code. So remember from our UI tutorial, when you use container elements, they determine the size and position of all their children, but we're not using a container element here. We're using 2D elements. They're not UI elements. So we can drag this and do whatever we want with it, which is super nice. So a couple things we're going to need to do. One is I just want to here pick some colors. So we're going to say export color var enable color, and then we'll say export color var disable. Let's make those past tense, disabled color. And so what we're going to do here is we're going to pick what color our color rec should be, whether that square is disabled or not. So what we're going to do is we're going to draw one of these color recs for in each of our grid squares to show whether it is currently enabled or not. So if I go here, I'm going to set our enabled color to be just a nice, pleasant sky blue or something like that. And here we'll do a pleasant pastel-y kind of pink red, salmon-ish, I guess, something like that. So when it's enabled, it'll be this blue. When it's disabled, it'll be that red. And what we can do now is first I'm going to get an onReady variable. So onReady var grid. And we're going to add all of our color X as children of this grid. And so we're going to eventually delete this single one that exists in our scene, but we're just using it as reference for now to know which properties we need to access. And so what we need to do is when we build up our traversable tiles, we can actually add a rectangle to each of these tiles and draw them right over it. So we'll just do it as part of the same pass. And then whenever we update our tiles, we'll go through and also update the associated rectangle. Okay, so when we're in this function for each tile, we are going to say var rect and set this to be color rect dot new. So we'll create a new color rect. And then we're going to say grid.add child rect. So we're going to add each one to our grid. And then what we need to do is actually set the position and size of each rectangle. So first we'll say rect.color equals enabled color. So we'll set them to be enabled by default. And then we'll say rect.rect size. And if you're wondering how I know what properties we're looking at, we're coming into our rect here. So rect size, you get rect size, rect position, it's rect position. So those are the ones we're going to be using. So we'll set our rect size to be, and there's a couple different things you could do here. You could just make it cover the entire, actually, yeah, let's just do this. Let's make it cover the entire tile at first, just to kind of show what that would look like. So we're going to make basically the whole tile be highlighted either blue or red, depending on whether that tile is enabled or not for navigation. So we'll do rect size equals tile map dot cell size. And then we'll do rect.rect position equals tile map dot map to world. So again, we need to get the current tile coordinates that we're on and convert it to world coordinates so we can set our rectangle to be there. And we will say vector2 of actually tile is tile, no it's not. Okay, so oh yeah, it is. We can just say vector of tile because tile is already a vector. I always forget that that's the type that it has. So we've got a size and position, so we are setting it to have basically a width and height equal to each of our tiles, and then we're setting it to the top left corner, which will cause it to draw for the whole tile. And so if I start this now, you'll see that it actually kind of ruins the effect with our game. Also, we're not updating it. So one thing we want to do, two things actually, is we'll actually set our rect.modulate property, and we'll just make it transparent so it's a little bit easier to see, or so that we can still see underneath our game map. So we'll just set it to 0.5 right now so we can still see things. And you'll see like now we can actually see the game. Everything is still blue because we're not updating it, but it's still there. I'm also going to delete this color rect now since we don't need it anymore. So now we are setting some transparency to it. And the other thing you'll notice is that if I click, I can't actually fire. And that is because you might remember this from the UI video, our mouse filters are not set correctly because our color rects are intercepting mouse events. So we want to do rect.mouse filter, and we're going to set this equal to be mouse filter ignore. So it's going to ignore all mouse events. And now when I click, we can actually still fire. So pretty easy. We're drawing a highlight over top of our map now, which is great. Now we can work on actually updating the color of each rectangle when we need, or during each pass where we go through and update things. So the way we're going to do that is to come down to our update navigation map, which we're doing every frame, and we're going to do pretty much the same thing that we did before. However, we're going to need to have a way to get the correct rectangle for a tile. We need to be able to go back and reference it. And so we need to set up a scheme where we can do that easily. Ideally, doing that would not involve using get node or get parent or anything, if possible, and we can avoid using the scene tree to get this thing. That would make it a lot more efficient because it's not efficient really to traverse the scene tree trying to find something. So what we're going to actually do is create a dictionary, and we're going to write our rectangles to that dictionary using a unique key, and then we can just use that key to instantly find them, and it's going to make it a lot more performant. So I'm going to say, let's come down here. I'll say var grid rex, just like grid rectangles, and this is just going to be this, so it'll be a dictionary. And then here when we actually add them, we'll add them, when we add our rectangles, we'll add those to our dictionary. So what I'm going to do is say grid rex, and then I'm going to add our rectangle here. But like I said, we want it to be a unique ID so that we can easily get them. And fortunately, we already have unique IDs. It's this unique ID we were using for our navigation grid. We can use those same IDs. So I'm just going to save these as strings and do string ID. We could technically just use the ID, but I think they get converted to strings under the hood. I'm actually not sure, but it doesn't really matter. We'll just stringify the ID for now, and we will set it to be rect. So we will save under the key of the ID, the value will be this rectangle, and then we can reference it later on, which will be real nice. So down here, when we are going through our obstacles and we get an ID that we want to disable, whenever we disable it, we can say grid rex, and then we can access that ID. We'll stringify that too. And then we can set the color to be disabled color. So we'll change the color of that rectangle to be disabled. As part of this though, whenever we're enabling points at the beginning, we should also set their color to be blue so that it's always updating. And so now with this, we're gonna color everything blue by default and add all these rectangles. And then we're gonna reset them all to blue each physics step. But whenever we have an obstacle that is blocking and therefore disabling a point in our navigation grid, we're gonna set it to be red. And okay, so we're also, we need to actually get ID. But in this case, when we do get points, it returns an array of the IDs. So point is actually an ID in this case. So we can just change this to be point. So now if I run this, we'll see that everything is still blue, but our walls actually are red. It's kind of hard to see because the tints are a little weird, but these are red. So it's correctly determining that, hey, these are disabled. And what we can do just to kind of see that that's the case is I can re-enable, just for this sake. I was trying to uncomment these, but I guess I'll just have to do it by hand. So we can re-enable adding units as part of our collision avoidance and do the same thing here where we'll color all of those red. And so now you'll see that whenever a unit steps on a tile, it gets colored red. So you can see which tiles are currently available for pathfinding or not. And this is really cool and really helpful, but it'll also illustrate one of the problems with using unit avoidance as part of our pathfinding algorithm here, which is I'm really right now, if I come all the way up here, like I'm really in honestly like 4 different tiles, but it's only ever picking one at a time. And so it means that our algorithm is not super accurate. In the previous video, I discussed some ways that we can fix it, but just wanted to highlight that you are going to see some weird inaccuracies with it. It's just, we just don't really have time to like go into all the different ways or try and fix that. But this is a way that you can see which tiles are enabled. And in a similar way that we did with our AI, what I will do is add an export variable here. And I'll say export, bool, var should display grid, which we'll just say false by default. And then what we can do here is just say like if should display grid, then we'll do all this. So we'll only add all these rectangles if we should display the grid. And then same here, we'll say if should display grid, we'll do this. Again, this is not super efficient, but if should display grid, whoops, we'll do that. And then same here, if should display grid. Okay, so if we should display the grid, we'll go through and do those things, otherwise we won't. And so it should be off by default. It is off. So if I do this now, we'll see, whoops, we will see that there's no grid. If I close this and just flip this back on, we'll see that there is a grid. So anyway, yeah, just really cool, easy ways that you can get some better debugging information about what's going on with your pathfinding. And again, just to show that even when we're drawing the grid, it's still not such a huge performance hit. We're still at above 65, and it's drawing all of this every frame. So that's really cool. Definitely adding the grid is a little bit more of a performance hit. It would be worse if we were trying to find grid tiles in the scene tree, but because we just cache them all in that dictionary, it is a lot faster. But yeah, so if I come into our AI and flip this on 2, we can see it all in action, where we can see real time how our pathfinding is working. So you can watch here and see that these update by the tiles that are available. You can see the paths change. That might be kind of hard to see. Let's make this a little bit brighter here. So maybe I will make these like a red, our path line, just so it's a little bit easier to see. So yeah, that's better. So now you can see all the paths that our units are taking. You can see them update and see how actors are moving to the next place and how that changes when something gets in their way. And see here, you can see the problem, right? Like this guy's trying to move here, and it's like the navigation system's detecting that, oh, he should be able to do that, but because the collision box of the unit is slightly in his way, and our navigation system isn't fully picking up on that because it's mapping each unit to the tile they're on, even when they're on multiple tiles. So again, just to demonstrate that that is still an issue, but guys, whew, cool. So not only do we have pathfinding and tons of features that we've added to make it feel good and work, we've also gone through and shown some ways to display pathfinding in your game so that you can help debug it and see what's going on. So, I'm really excited. Pathfinding is such an interesting topic to me. I am glad to be done with it, though. We just spent a lot of time covering it, but I hope that this has just all been so helpful and cool and just showing you things that maybe you wouldn't have thought to do or would be confused, or maybe we're just didn't really know where to begin. So hopefully this is a good starting point, and it's something that can just continue to push you further on your own game dev journey. As always, let me know in the comments any questions or feedback you may have. Again, hop into our Discord, link in the description if you need further help or just want to hang out with people there. And I'll see you in the next video.